Cool. Welcome everyone to the January meeting of the Philly Azure Group. Appreciate you all for showing up and coming. Also, thank you to everybody who is live in our Mixer channel. And in the future, thank you to everybody who is watching this on our YouTube channel way after the fact. We have tonight a few announcements, and then we have a couple of really good sessions. One really good one from Rich on architecting container-based solutions in Azure. And then probably an OK session on Azure Service Bus, where I hope to enlighten everybody on a lot of the architecture patterns and information that you need to know around Service Bus and Azure Relay. And then we can take any questions around that. I will defer to Rich for most of those questions anyway. But that's good. Hey, if you're on Mixer and you are listening and you're not on Mixer in this room, please let us know how the audio is coming through. I hope it's well. Also, we're monitoring this during the meeting, so if you have questions and you're online, speak up, raise your hand, ping us. We're watching, and we will definitely get to your questions. Couple of your normal user group announcements for this month. Next month, we've got a meeting. And we've got speakers, and we are working out the logistics around that. So apologies that we don't have that ready to post. The tentative date is looking like 2/12, which is a Monday, which is different for this group. But that has yet to be confirmed. Stay tuned. That is the machine learning and data science session with Dave Voiles from Microsoft, who's fantastic, which was supposed to be tonight, and it got pushed out due to work reasons. So no big deal. We'll get that in February. And we have another session, Azure, I want to say it's Data Catalog. God, I'm drawing a blank on it. I think it's Azure Data Catalog, and that'll be the other session of the night. So two good sessions coming up in February. We also have our March sessions booked out. It's going to be tentatively on Azure SQL and Azure CDN. So please stay tuned to this channel, to this YouTube, or come to the meeting directly. One other thing I want to do, because I don't have a ton of Azure news just live and ready to roll, is if you are in the meeting, if you are, and this can be anonymous, just close your eyes. If you are looking for a job, you can raise your hand. And if there's anybody whose company is looking to hire people, you can raise your hand, and y'all can meet up afterwards. If you are in the Mixer stream and you are looking for a gig and you're cool with saying that online, feel free to say that, and we will try to find that as well. So we definitely want to connect people who are looking for jobs or people who are looking to hire people for jobs. There's one. We got a hand wave. We got a couple of hand waves. Good. Awesome. Everybody hang out later and we will figure this out. The one bit of Azure news I will point out, selfishly, if you go to my blog, timferro.com, there's a recent post on Azure CDN, but it's on dynamic, and now I'm drawing a blank. I really should be better prepared for this. It's a subset of how CDN works, but it was really interesting, and it was something I didn't know about until recently, even though it was launched in July. It's called DSA, is the acronym for the service within CDN. I found it really interesting, and there was a really good Channel 9 video with Scott Hanselman on it, and it has to do with caching, but for dynamic sites as opposed to your normal CDN usage. So I found that really cool. I wrote a quick blog about it, which mostly just points to a video from Hanselman, so check that out. Lastly, we do need a sponsor for all of our meetups going forward, so we would love to have a sponsor. If you're listening and you want to sponsor, please get a hold of the group. If anyone else who's listening knows somebody or wants to sponsor, we would love to have you. And the sponsorship will go to, it just goes to the food for the meeting. We don't have really any other needs, but people really love that, and so do I. I do wish we had food. Other than that, that's basically it. You buy for the meeting, and you get to come to talk for a couple minutes. You get recognized on the Mixer channel, on Twitter, on our Meetup site, and any other medium that we put it out. So there was that, sponsor needed. So without further ado, we are getting ready for architecting container-based solutions in Azure with the wonderful Rich Ross from Microsoft. Rich, take it away.
Thank you, Tim. Probably should clean this up a little bit since we're doing some testing. All right.
So, gonna level set here. How many people are actually working with containers as part of their day job? Nobody. So 1, 2, 3, 4, 5, 6, 7, 8, 9.
Starting.
You're starting to.
Yeah.
That's okay. We'll count you as one, so I can get at least not a 0. Right? We don't want to start with a 0.
Yeah, you know, piloting.
Okay, that works. Okay, so that end of the table basically is where all the container knowledge is. It's a little less. I've done some sessions. We did a Philly.net session back in over the summer where we talked about containers as part of our Azure Lab series, and that was I think we had about 5% roughly who was kind of there. I've done a couple of other talks and kind of in that same 5-10% range of people who are actively doing containers. One of those things that, I mean, for me, containers is, we're kind of at that, start at the bottom of what I think is that inflection point. A lot of people are starting to use it, a lot of people are really starting to get into it, but I kind of equate it where a lot of people, when we talk to customers, have been with IoT, maybe a couple of years ago. IoT has completely taken off. There are all these great solutions where we've tapped into machine learning and we have some great stories around that. I think we're at that same cusp, where we're just starting to take that trend over the course of the next couple of years, which is really going to start to explode. So it's great that you're here and you're able to start to understand and start to get aware of what's going on with containers. So since we're kind of at that level starting ground, I don't have slides. I was just going to kind of whiteboard and talk through and answer questions and see kind of where things go. Just kind of make it open and interactive, as it were. So what I'm thinking of doing is, let's just talk about containers first in and of themselves. Okay, let's talk about the container technology, as it were. Let's see. So one quick check. How's the volume on that? We've got a new mic system here. So too loud? Not loud enough?
Seems okay.
Seems okay? Okay. Now we can boost the gain a little bit if you think it will be.
Well, start talking from there and I'll go boost it if it's...
There you go. Talk as I would normally present, right? Because now I'm kind of thinking about what I should be saying over the course of the mic there. It'll work? Okay. All right. So, containers. First of all, let me ask, what is a container? Anybody? Come on, guys. I got an hour to talk.
It's like a whole application and infrastructure all wrapped up into one thing that you can put on a virtual machine, on a container running machine.
Exactly. That's a great way of summing it up. So it is a self-contained, self-descriptive application that you can scale out and up and down independently, let's say. Okay? Just the kind of, because we had, was the foundation for it. What I think you caught yourself, importantly, containers is not, they're not VMs, right? It's a different technology. We've been building, I come from the SharePoint background, so I had a machine that was way too heavy to be carrying around in a backpack with a number of virtual machines on it, and you would start with a machine with a base operating system that was layered on top of it. I would install all the frameworks and all the pieces I needed. I would then go ahead and install my application on top of that, right? All of those components that are there, if we think about the virtual machine size, just kind of, for the people who might be online or watching this later, so if you look in the VM world, I have some kind of an operating system, I have some frameworks and things of that nature that my application needs to run. I also would then go ahead at the very end, layer on my application. And you probably can't hear me because I'm facing the wrong way, right?
It just muffles just a touch, that's all. It's, you were audible, but you can definitely tell that when you turn around, it starts to muffle.
Yeah. So,
Up the gain.
Up the gain? I think that's good.
Closer.
Cool. And I'll try to face this way being left-handed. So for those on the stream, this is our second time doing this one. First time with the microphone. It just arrived from a large online supplier earlier today. So, so we essentially have a way of being able to.
Do they use containers?
They might. So if we have our virtual machine here, and we would have those. We would spin those up. If I wanted to create another one, I would go through the process of going ahead and creating all of these various components together. I might have some kind of a shared disk that I could kind of build my application on top, or my second virtual machine on top of. and have various ways of networking and putting those components together. Those things, when we did them, they're kind of heavy, right? You would typically allocate 60 gigabytes, 50 gigabytes of disk space to be able to store your virtual machine and have it up and running. Okay, so a much heavier weighted system. If I wanted to make multiples of those and I wanted to scale out my virtual machines and have them, because of the load that my application is running under, if I wanted to spin all of those out, it's going to take a couple minutes for that virtual machine for the operating system to boot up, for the frameworks to load, for whether it's IIS or whatever kind of middleware is there, and then my application to kind of run on top of it. All of those things take time. So now that I have that second virtual machine up and running to meet my demand may be gone. Right? So now I've got to figure out how do I spin that back down. So that's kind of the virtual machine world of running things. Things are very different over in the container sides. Inside of your container, you essentially have, it is aware of the kernel of the operating system that you're running on. So that means that we basically have two possible flavors that we could be running inside of. We could run inside of a Linux container, or completely separately, just to draw that out for effect, we can run inside of a Windows container. So based on that, you kind of start with this lowest level of container image. So we would go out and we would say, I want to build my application, I want to base it on a Linux container image, and I would go out to a repository and pull that image down. I could then go ahead and, much like I did on my virtual machine, put on additional applications or frameworks that I might need. So I might need some kind of a web server. So in this case, let's say I use Nginx, which is a very popular Linux-based container server for hosting your web applications inside of. So I could have that running inside of there. And then from there, I get to go ahead and put my app sitting on top of that. If I did this on the Windows side, maybe I have a an IIS container image that sits on top of this, and then I can put my Windows .NET framework-based application running inside of here. Process is very similar. They're just different frameworks and different things that you would go ahead and make those components happen. Each one of these is essentially an image. So in the Docker world, where does that image come from?
Repository.
Awesome. So we have some kind of repository, some place where all of those images are basically hosted. Now, there's a number of possible places for that. Docker, which is a common, Docker, which provides a lot of the framework and a lot of the tooling around building containers, provides their own repository for you out there. It's a public repository. Anybody can access it. From the Microsoft side of things, we have a lot of public images out there in that repository that you can use to start building your application against. There are also private repositories. So Docker has a private repository that you can buy into and decide that I want to host my images up in this repository, but it's going to be private. So it's mine. Anybody who needs access to it, I would give them the keys and the credentials so they could sign into it and be able to pull down those images. So you have a way of locking and creating your own images or pushing things out into a public image. So while this is an image here, you can actually create an image that contains both of these pieces and have that stored locally as well. So you could download an Nginx image out of the Docker repository. Once you go ahead and start to layer in your application, I now have essentially another image that is saved locally in my Docker images collection. So essentially I have, as I start to layer and push these components on top of each other, I have a way of customizing an image that represents my application, right? So how does it know what's involved in my application here? How does it know where to start? How does it know where to put the right pieces inside of there? when you build out your application, you do something called a Docker file. And a Docker file essentially has some basic information you need to build out your image. It's going to say, what's my base image? So what am I using as the foundation that my application is going on top of? So in this case, my base image is going to be this Nginx collection of images. So that's my base image, and I would list that in here that I'm using Nginx. And then I would tell it, well, where is my application coming from? So I'm going to go ahead and compile an application, and it's going to reside in the /app folder where my code lives. So this is where we're going to go ahead and push that code. So as the compiling happens, this component here is going to wind up being dropped into my application as it exists there. Other things I might expose here, this is a web application. I want you to go ahead and expose out port 80, make it available so that people can talk to my application. And then I might also have some additional settings inside of there if I have other components that I'm talking to as well. So that, from a basic perspective, is what a Docker file contains. Where this is a really cool thing, and why everybody's so interested in containers, is if I want to deploy that anywhere else, that's what I need. Because what's going to happen is and Docker. Docker's going to be running on some other system. I could take this file, I can put it in my source repository, I can deploy it out to another machine, paste, thank you. And that other machine has everything it needs to know to run my application and to build it up right. So what does this get around from a developer perspective?
Works on my machine.
Thank you, yes, there you go. No more the excuse of it works on my machine. It is going to work wherever that definition kind of came from. So very important, very powerful. We get that repeatability. Because we're able to be repeatable and be able to continually build our application and be confident that as I make updates to my application and that Docker file pulls those components together and is able to push those out to the test and the prod environments, I am more comfortable making changes. If I'm more comfortable making changes, I can iterate faster on my application, and I can get to that point where I'm comfortable getting changes put into the environment much quicker and getting features rolled out as needed in a more agile manner, basically. Questions? Okay.
Do the Windows containers or the Windows Docker files and the Linux Docker files, do they have different kind of formats at all, or is it just the base Docker file is different and then the tree works that way?
Exactly. The structure of a Docker file is essentially the same. It's the base image that gets called from, or that gets created as the start of it. So whether you're starting from, this layer here, oops, I'm gonna change pins back. Whether you're starting from this layer here, and my Docker file is starting from the bare minimums, or my Docker file is essentially saying, hey, I know we want you to go ahead on out there and do an IIS image, go pull that down for me and make that run. So it depends where you want to start, but the structure of a Docker file is going to be similar regardless of those. What may need to change, and we're not really talking about or showing how you would spin up locally a Visual Studio, your Docker containers, or those kind of things that are running in your environment, but be aware that if you have a Docker container, at least for right now, you have the ability to, when you do the settings in Docker, you have to make a decision. Am I going to run Linux containers or am I going to run Windows containers? You can't run them side by side at this point.
Gotcha.
Don't know when that's going to happen in the future. It'd be great if it did, but right now you can't.
It's in the beta channel for Docker,
Docker?
for Windows.
Okay.
I think in the beta channel, you can now run them side by side.
That's cool.
It does not work that great. I had to go back to the stable channel.
Yeah.
Is it-
Today, you actually switch. You say,
Right.
I'm Windows now.
In the beta channel, you don't have to switch.
Okay.
It's just you run Docker for Windows, and you tell it what kind of, in your Docker file, you say, pull a Windows image,
Right.
and it just spins it all as this micro VMs on Hyper-V.
Okay.
But you have to have the Linux Linux subsystem installed, the Windows Linux subsystem, and you have to have something else enabled too. And I was able to get the container running, but then I couldn't get any of the networking to actually map the ports properly. So
Okay.
yeah, so it's just one of those. I'm sure if I tried it again, it might work this time. Who knows?
Interesting. Okay, that's good feedback. I didn't realize that beta channel was out, so that's pretty cool. So depending on, and this might be part of the networking behind the scenes stuff that's happening, so if you're running Docker locally on your machine, you are running some kind of a virtualization technology inside of there. If you're on Windows 10, you can run it in Hyper-V, because that all comes kind of out of the box, and you're able to use that. Previous versions of Windows, because they didn't have the Hyper-V, you had to install VirtualBox or something of that nature to make it run. And we've had to do that with some of the labs that we've done here where we've done containers. So that virtualization technology is where those containers are essentially going to run inside of. Okay. All right.
Hey,
Yeah.
quick question.
Yeah.
The instance which you kind of carved out there, which you said that's from the repository, right?
Uh-huh.
Yeah, this one. And then you spun off another one. What is the relevance of that? I mean, is that deployment on every server where we want people to be logged on? Could you give me a perspective, like what is this?
Sure. So this could be a Docker file that's running locally on my development machine,
Right.
and I have it here, and I'm running it locally. I'm testing it. I'm building it out. I get to the point where, hey, this is pretty stable. I'm going to push this into my source repository.
Right.
I might use something like Visual Studio Team Services to be able to go ahead and push that Docker file up to, and all the code that goes along with it. I could also then do a build and a release cycle out of that would then take this Docker file and push it off to my test environment, wherever it is we're running containers in our test instance, or wherever we're running containers in our production instance.
So that's just is that like what is it? Is there like a kernel image? What does it have?
It is essentially just I don't want to say a text file, but it is a file with text in it that defines, with a couple of at least key required properties in there that defines what Docker needs to do to build out that container.
It's a schematic for an operating system.
There you go.
Okay.
It's a blueprint for how Docker should instantiate a new quote-unquote machine.
Okay.
And so based on that, you can make more machines.
Mm-hmm.
So now, just a little bit,
Yeah,
without,
yeah.
without making too much. Like, so here is a setup, developer's machine has some properties, some configuration, let's say some CPU settings, some memory. So it works like a charm, great. But when I'm deploying, I want to preserve that, but when I'm onto a bigger server, mighty server, I want some of its so-called better features from there
Mm-hmm.
without messing with it. Does it make sense what I'm saying?
I think I get what you're saying. So there are other, this is basically defining the container, the instance of your application running, and the parameters around which it runs.
Right.
Regardless of whether it runs on my desktop machine under my desk, or a server class machine running up in our data center, or even our virtual machines up in the cloud environment. Regardless of the processing power of your system, that container can still run in all those places. Where I think if I understand where you're going, is I've got more horsepower on that machine
Yeah.
that's sitting out there.
Would it limit it? Would it inherit some property which would be like, oh, I'm in my cocoon, oh, this should work here, oh yeah, but hey, you got some fancy server here. Why can't you, without messing with parameters and
Right.
I'm talking about something like, hey, you got like bigger room here, stretch it out.
Right. So where that is going to come into play is in something we talk about later on called an orchestrator. So this is one container that has essentially just a web application inside of it. We have it in our dev environment, we move it to test, we move it to prod. It doesn't really need to understand and know about the performance capabilities inside of that environment right now, because it's just kind of running within the normal set of specs. There's another construct we'll talk about in a little bit, and we can come back to that, your horsepower example and how that plays into it.
Essentially, aren't you're just going to end up running more instances of your Docker image to consume the horsepower,
Oh.
I think, and then you're going to talk about that.
Exactly.
How that happens.
Yep, you got it. All right. So we have our Docker file with our simple image here. You can also so while that Docker file can talk about what it takes to spin up that container and make that container run, there's also another file that's that you can include in there called a YAML file. And that YAML file essentially talks about how multiple containers can exist together and how they might talk to each other. So while the Docker file defines how that container itself runs, the YAML file, also done without the A as well, I've seen it written both ways, both get acceptably read by the Docker engine, is able to basically understand, okay, I've got a container that I name my web front end. So that's what this one defines here. Okay, so I've got a Docker file, built out container, and then I've got my YAML file that says, you're going to use this Docker file to build out that same container called web, okay? I might also have a caching container to be able to store data that comes off of some other system or what have you. So I have a Docker file here that is essentially using an image from the Redis image as the basis for my container. So, and then this one over here is being defined as a cache. So I'm building out this application that's got a web front end, it's got a caching container, and then we have some communication that kind of is exposed between them with the ports that's able to talk to those environments. So now I've gone from a simple container that has my application in it to actually a small little application that's defined with this file. And much like with the Docker file, I can take the YAML file with the configuration information, I can push that into Visual Studio Team Services, I can use build and release processes to push that out to various environments and make those things happen and work. Good so far?
Yeah.
Okay. So while we had, so that kind of level sets things at the Docker level, understanding why we have containers, how our applications
Sure.
get built,
Sorry,
without going into
question. So when you define the multiple containers in the YAML file, in your example, that Redis cache, is that only accessible with the ports that you expose there from that web app container that's specified in there? It's not open to any other containers that are not defined in that?
that would be, yeah, you would do the mapping between those, the ports that are open between those.
But that's
two
not
containers.
publicly open for like a third container that's not specified in there to use?
That would, yeah, that would be
Okay.
correct. Yep, there might
So
be
it's
other.
all still self-contained?
It's all still self-contained, yes. Yeah, now where that gets a little fuzzy for things on port 80, they're gonna be, you know, those web traffic things are a little more accessible than something like a caching or
But
database.
you still have to map what your internal listener port is to your external port, right?
Right,
Yeah.
you do. You do. But you, I guess what I'm saying, the web traffic is gonna be, if I'm exposing traffic over port 80, we're gonna be able to see that regardless of the
Oh, yeah,
container
yeah.
it's in.
If you were running like a whole bunch of web containers on one host, you would map their port 80 to a bunch of different ports
Right.
over those.
And hide them,
And
basically.
hide them, and then you have some sort of load balancer sitting in front of that to load balance on those ports. Something.
That's getting, yeah.
There you go. Don't want to get too far ahead.
We'll talk about that in a bit, yeah.
I guess that was my next question. We talking in a bit about the port mappings and all within the containers at all?
We can. Do you have a certain?
No, that's new to me, so that's for just a general Docker knowledge. So I didn't know what
Right.
considerations there are.
So you can map off of the Docker file. You can map what essentially is your web application running in port 80 to some other ports that's accessible off of your local host, let's say, because it's all running in your local machine right now. So you could say this my web application front end is running off of port 80. I'm going to expose it over to 32413, and then that's how I would address it. So when the routing happens, it's going to see 32413. Come to this container here. The container says that's fine. I know my traffic for you is on the port 80 for my web application that we're running.
Okay.
So
I guess that's for local use.
Yep.
Is there any considerations you have to do once you're deploying?
there'll be considerations for that when you get to, and there are other engines we'll talk about when we get to
Okay.
those pieces. Yep.
Okay.
All right. So why are we why are we going down this path and doing all of this and putting things in containers? I was able to, you know, run my IIS based or you know, running a local web server on my machine, hit F5 in Visual Studio using .NET Framework 4.6, and everything was off and running, and I was happy. Why are we being moved over to containers? Well, a lot of the discussion has moved to, or one of the reasons that people are starting to look at that is not only the repeatability and the ability to go ahead and repeatedly produce your applications to whatever environment you're pushing it to, but also something called microservices. So not just because I have an application in a container doesn't mean that I have a microservices architecture, right? But because I want to do microservices, I want to be able to have applications that have some certain, that are not kind of contrary to microservices would be those monolithic applications. I've got this huge app, I have this huge complicated process that takes place to deploy it. If I want to update something inside of there, I have to basically retest everything because it's all a little bit spaghetti together, but it's certainly all kind of mixed together and is a little bit more intertwined than I would like. So what microservices gives you is that ability to deploy applications individually. So I would have my service sitting in a container here. I have my service 2 sitting in another container, and then service 3 sitting in a container over here. Whatever it is those containers might be doing, from a workload perspective, one might be a front end, one might be processing orders that are coming into the environment, and this one might be go ahead and trying to do some kind of order fulfillment side on the back end. But what this gives me is, because those are unique and discrete processes, I can spin these things up and down as necessary to meet the demand of my application. So if I'm really getting hammered with people coming out and hitting my site because it's Black Friday and things are going really great, I can essentially make duplicates of my services, my web front-end services that would go ahead and run outside of here without having to impact those other services that are sitting behind there. Okay? That ability to segment those out gives me that flexibility. It also is one of the things that, how many people are actually, when they're building applications right now, thinking about the microservices kind of framework and starting to build that, going down the path? Okay. So we're thinking there, but we're not in containers yet. So we're
starting on the path of Service Fabric. So
Okay. Using just some of the native Service Fabric constructs like stateless and stateful.
yeah.
Okay.
Start with that Visual Studio template, Service Fabric, ASP.NET Core stateless, and by the way, that template doesn't produce you an ASP.NET Core API. There's a glitch in the template where it produces a .NET Framework 4.6 project.
Oh wow.
There's a topic out there, and somebody from Microsoft identified that we're not going to address it in this release, but it was kind of a dead end. But, so you kind of got to like hack around it,
Okay.
and like modify the CS proj and then update the Service Fabric packages that get implemented automatically.
Okay.
But you got to use a preview edition to get through all of that.
Oh wow.
I don't know if it's works the same for the stateful, but on the stateless, I just kind of uncovered that this week.
Okay.
Trying to put that all together.
Interesting.
Kind of an oddity, but
We should talk and make sure things are kind of rolling along that direction
Okay.
for you.
So Rich,
Yeah.
it seems like you're heading this direction. There's a question here that the basic question is it possible to use Kubernetes with Docker? But the person asking the question acknowledges that they don't know much about both, so they're probably useful to do some level setting, and it
Yeah.
does look like you're heading towards orchestration.
Yeah, we're not there yet.
Okay,
Yeah.
so
Kind of
if
define the
it's coming in a
difference.
little
Yeah.
bit, then we can say we're almost there.
Yeah, we're
There
getting
was
there.
one more question that says, does inter-container communication require the containers to be on the same host?
Inter-container communication between the same host. I don't think so. Yeah. No, they can be across because you're gonna have containers on different hosts when you actually push this out to production anyway, with them being on different nodes. So yeah. So no, it does not.
Yeah, like if you think of them as that they might be on their, even though they're not, they're on as if they were on their own virtual machines anyway. You would have inter-machine communication just like normal.
Right.
There might be some nuance to the question that maybe can get clarified. And then as in terms of the first one, I think you're just about to get to defining some of these tools and purpose. So
Stay tuned. Don't go there. Yeah.
Don't go
So
anywhere.
this was as we start to think about, we're kind of coming at this from a couple different angles from here, but Docker was just kind of that base discussion we wanted to have. Microservices is kind of where things are heading. How can we kind of use the microservices patterns that we're thinking about to get there, and what tools do we need to do that, and how does Azure and all the various services that are there help us do that? Yes.
Yeah, just a quick question. Could you draw like a, if I may say, starting from the OS level and all the way how the microservices architecture kind of, just very briefly, like, we are saying, okay, the container, then we're going into microservices, just teeny bit like, okay, this is how it puts another layer, and, it's kind of a, like we could launch multiple services. Because I know you kind of laid it out that, okay, we'll have microservices, but I'm not sure conceptually all the way from, okay, where you've got like OS level and different layers, and then how it reaches and where it kind of separates from another service running on the same port, if I may say.
So let me see if this kind of goes in the direction you're looking to get to. So if we think of each of these boxes here, right, are essentially containers. And we know a container, based on what we drew up here, has these layers of images inside of them, right? So whether we're building it off of, a base image and then my application sitting on top of it, but essentially it's made up of stacked layers that we squash down into a specific image that then every time we spin one of these containers up, we use to make we basically use that to make that, instantiate that container, right?
Right.
So your kernel awareness, your framework that you might have included, and then your application is what's sitting inside each of these boxes. So every time I stamp one of these out, that's what I'm spinning up, essentially. All of those can be running on some kind of a color. On some n number of virtual machines that we call nodes. And we'll talk about that in a bit when we start talking about some of the services and how we would use this going beyond your local development component.
So is there some semblance of mapping between, okay, there's one virtual machine, so there will be corresponding one service or multiple services underneath one virtual machine? What is the...
Hold that thought,
Okay.
We'll get to that.
Okay.
Good. You're going in the right direction, much like the guy on the or the person on the chat window as well. How are we doing on time? We're good.
All the time in the world.
Sorry?
We have all the time in the world.
Okay.
Till the lights go out.
Yeah, I'm the one who pulls the plug, so we're okay.
Then you're good.
Okay. I'm trying to think of my train of thought. Okay, so essentially, microservices architecture, and being able to do that as part of a container strategy, where I'm probably going to go down the path of the person on the chat, in that, okay, I've got these containers, but how do I manage the deployment and the health and the care and feeding of those containers? So just to kind of backtrack a little bit, when we talk about Docker, Docker is essentially, it's become ubiquitous with the term container, okay? We have, it's almost like, I refer to it as the Band-Aid of containers, right? It is what everybody is used to using. When I say I'm going to spin up a Docker container, or a container, I'm going to spin up a Docker container, actually put that nomenclature in front of it. But in essence, containers are a construct of the Linux operating system itself, right? You can just in Linux spin up your own set of containers. Docker has just made it much more easy for the developer to instantiate those containers, manage those containers. They also have their own ecosystem around it. We talked about the repository that you can use to store images, the Docker CLI, so you can store your images locally on your machine as well, to be able to spin up containers locally with Docker Compose and things of that nature. So Docker has built this whole ecosystem that everybody has really made synonymous around containers. But there are other forms Rocket is the one, RKT is the one that we typically talk about when we talk about other types of container properties. But understand when you talk about containers, Docker is just a specific flavor of that property and makes it much easier to do. As we talked about over here, Docker is just going to instantiate that container based on the information in the Docker file or the YAML file that you created. If we think about the applications that we're building, they're a little more complex. We talked about being able to spin up multiple containers, have them talk to each other, and to do that, to be able to kind of meet this demand that we talked about here about spinning out that front end set of servers, we have what are called orchestration engines. So that takes us from a different level. So Docker being that container part, orchestrators being the that engine that understands some of the key components around those containers. How is my container performing? Is it performing healthily? Are there health issues with it because of some update that might have happened? Are there performance issues because we're starting to max out the CPU that's available to that container? And that because of that, I need to now start spinning up additional containers and make my application more responsive because it's getting hit with a high number of demand. So orchestrators kind of help pull that out. You can have those kind of performance metrics, measured inside of your orchestrator file, and that is also a YAML file that defines what that orchestration looks like. And there are a number of different orchestrators that are possible when you start talking about building out your applications. So Docker, in and of itself, has its own orchestrator. Originally, there was one called Docker Swarm. There is a new version of the Docker orchestrator that is available as well, and I'm blanking on what the name of that is, what their new version of that is. But essentially, that's their flavor of it. There was another one from Mesosphere, DCOS. So they had their own version of the orchestration engine, and then we have another one that is really kind of taking off in popularity, called Kubernetes. And what all of them give you is essentially that flavor of managing your demand, managing your deployment of your containers, and managing the health of those containers as well as you continue to deploy those containers out into the environment. So you have some options inside of here. All of those are essentially kicking off and starting containers regardless of which orchestration system you're using. So you have the flexibility to use the orchestrator that makes the most sense for your application or your work environment or wherever whatever choice your development team decides to use. And there may be different reasons why you've decided to choose one over the other, but they are certainly all supported from a container perspective. Does that kind of help with the, was there any feedback, I guess, from the Kubernetes discussion?
Just said, I was going to ask about container health management, but I guess that was already answered.
Right, yeah, so it is part of what your
All three of those examples, Docker, Swarm, Kubernetes.
would be able to handle those, to see the life cycle, see how things are progressing, and whether they need to spin up more or shut them back down.
I can kind of imagine what these Docker files look like because it's basically some kind of dependency graph in a linear fashion, right? Of saying you want to build on top of, but I can't imagine what this is. An orchestrator file? Like, I can't imagine how that looks. Like, what kind of stuff is in there? I can't imagine a file that says, oh, if this server is failing, then increase the performance, or increase, or new up another one, or something like that.
Yeah,
Can you
so
clarify?
you don't have one of those handy. Let me see if I can pull one up real quick.
The one that Kubernetes uses for complex deployments is called Helm.
Okay.
So you deploy I think the deployment item in Helm is called a map. Something like that.
Yeah, so there is that Helm component, which is
Right.
one of those set of tools that Deus, Helm and Brigade.
chart.
Helm chart, yes.
Map chart.
It's all part of that seafaring Captain Ahab, looking set of tools that are there. But those are, so Deus and their tools, Brigade, Helm, and Helm charts and things of that nature are all part of open source tooling that I think we acquired, I forget how long ago, it's within the last year or so. But the Helm, so while Helm kind of, from a DevOps perspective, can help make things a little more repeatable and help package those things up so that they're possible, that's not the only way to do it. You don't need that to run those Kubernetes components with those statistics around it. So there's essentially, we'll find a file and I'll send it over to you, but it's essentially there's like a max CPU and a min CPU for each container
So they're pretty
definition.
legible.
Yes.
Okay.
You
Like
can
a
find
number
those.
of containers too, right? Like,
Yeah.
I want 6 containers for my web node. I want.
Like a range or something.
Yeah.
Yeah.
I
Exactly.
don't know if it does do a range, or is it? Do you have to set
You
some
set-
monitoring software?
Set
to
them in
tell?
max.
Do you? Okay.
Yeah.
And then do you have
Or
like a
it's-
monitor in
what do
there?
they
for-
call it? It's like a replica set or something.
Yeah.
Yeah, I think I
I'm
have
familiar.
one somewhere.
You can set them in
I
max,
started going
so
down
it
the
won't go
Docker path. I haven't
over.
quite gotten to the
Yeah.
Kubernetes
If it needs
path.
to spin up more, it won't go over that max. But you don't have to set it in max. You can set a, you're going to instantiate my Kubernetes or my Kubernetes is going to instantiate my containers, spin up 4 of them for me, and just keep an eye on the metrics for me without setting them in max, or you could set them in max. You have that flexibility there. You can also override those. So if I want to override what's written in that YAML file, when I spin that up, I can change that property and say, give me 4 instances instead of the 3 that's specified in the file. I can do that at runtime and kind of the last one in from an environment settings property perspective.
Would
Yep.
Service Fabric be considered an orchestrator?
Yes,
Okay.
absolutely. So that's if you're going down the path of deploying containers into Service Fabric, because you can do that, then Service Fabric becomes that orchestration engine.
Okay, so you
Go
might
ahead.
be getting to this. When, say you're going with something new right now,
Mhm.
containers,
Yep.
Service Fabric or AKS? Because I can't get this answer from anybody at Microsoft. There's reasons for that.
No
You can go
pressure.
Offline, but
Was it between again? It was Azure
Well,
Container
it
Service or?
yeah,
Yeah.
exactly. Depends on what you need.
Spoken like a
Depends on
true
what you
consultant.
need.
Can we table that one till the end?
Sure.
I don't want. We will
Certainly
address
can.
it, but I think it's fair. What I'd like to do shortly is let's talk about what Azure container, what's possible for containers in Azure, and then sum up and kind of come back around and say, okay, when do I use what?
Okay.
Sound fair?
Yep.
Okay. Yeah.
Can you explain the reason why, if I'm dealing with a virtual machine, which is like kind of behaving like, you need a little bit more horsepower, I throw, okay, and bump in more memory or more CPU or something on those lines.
Yep.
But if I heard you correctly, if I have to address a similar, need on a container environment, I heard like spin up more container. Can you tell me like why a single container cannot be like, kind of pumped up or whatever, like given more horsepower rather than spinning more? I'm not able to understand the rationale why.
Yeah, excuse me. So the reason why you would want to do that is because the ability to spin up that container and have it go from nothing to being up and ready to answer requests and process work is like less than seconds. They're that quick. Whereas if you were to try and figure out how would I make that container bigger, I've got to.
Downtime?
There could be not so much downtime, but I've got to take that other container and spin it up in a kind of a different. I think the right way to say
You can
that.
expand, it can expand, increase its memory footprint or something, or if, let's say, RAM is a consideration.
No,
Yeah.
I guess it
But the container
boils
doesn't-
down to the horizontal scaling versus vertical scaling.
Right.
Yeah, yeah.
That's a good point.
Well,
You're scaling out multiple instances. So horizontal scaling about being able to scale out multiple instances of the same thing
Right.
versus a vertical scaling of being able to scale up.
And eventually horizontal scaling is much more efficient than vertical at the end of the day.
Yeah, exactly.
You
Exactly.
definitely hit a limit with the vertical scaling.
Exactly.
Very quickly, and so the horizontal is much quicker to scale and
Efficient.
can handle a much larger volume.
Yeah.
There's also,
Good point.
depending on what service you're using in your container, in the example, it was Nginx. which you could pass to it as part of your Docker file, some parameters for memory usage and such, I believe, or, you know, something a little more involved, like an application server or something, where you're passing it, and that part of that Docker file may be, well, my application running in this application server requires this amount of memory and such as part of its parameter for how to start your application. So that there still may be, depending on what you're using in your container, memory definitions and such, like minimum, and then you have to make sure that the nodes that you deploy on can support that.
Right.
So just one last question. So
Sure.
in case we are going this route of horizontal, scaling, so let's say my application has latched on to one particular container, and it has some kind, if I may use the word affinity, that okay, it's latching onto it, or it is tied to that, there is some, let's say, persistence or whatever. It's like, okay, yeah, I have some transaction going on. Now if you spin another one, how is it that related that, oh, I'm part of the same one?
So what you raised is a really interesting, or it's a change in the way we think about architecting our applications, where we have to architect them in such a way that we don't have state residing inside of your container components.
So that's
State-
a prerequisite. Like
Yeah,
the moment I go through a container-based architecture, that it'll be like a one-to-one, like okay, what you see, okay, this is a transaction, no relation, there is no spinning off, there is no passing on the baton.
Essentially you
But
want to
it's
make
not
sure.
it's not a prerequisite, but it's a best pattern.
Yeah, definitely.
That's so you'd like not to store the session cookie or anything in that container, rather you hit in the database and get that rather
Right.
than within the container.
So a single heavy transaction which says, oh, I need more space, you say, I mean, I'm not trying to wrap my head around like, okay, so
What
there's
kind
one
of
single
heavy?
transaction which is very heavy, trying to beat up one particular container,
Mm-hmm.
and you say, oh, I'm hitting the limit, and we say, okay, you spawn off, but there is that transaction cannot spill over, or I mean, I'm trying to say, how are we giving it more horsepower to, let's say, a single heavy ton, let's say,
But the
a
container
hypothetical-
itself doesn't have the horsepower.
Right.
Right.
I get that. What I'm saying is a transaction which is launched, let's say if we say this is a unit of work which is going to be launched,
Mhm.
through utilizing a particular container. Okay. So now it runs a rollback in terms of some capacity, some resource.
Okay.
So now I say, okay, now I shall give you more.
But it's kind of like load balancing at that point, right? I mean,
Yeah.
it's your transaction went to that one first container.
Right.
It's using a lot of resources, and now something like one of the orchestrators is going to say, that one's bogged down, so we're going to spin up other nodes, make it more available for other traffic. So is that an accurate
Absolutely,
depiction?
yeah.
Okay. Fair enough.
So
Thank you.
yeah, so that first one though, but if I did the work on that first one, I go back, I may go back to, because other containers are spun up, I may go to another container 4, gives me that same bit of service, but it doesn't know that I don't have to know that I was back on container 1. I'm going off to a different container. So your application has to be architected in such a way that your containers are essentially stateless. They can spin up and spin down as needed. Not a prerequisite, as you pointed out. It's a really good idea and a really good practice to kind of re-architect your applications as you move them into this kind of a pattern.
I think I'm still a little bit, I was beholden to the threat model, or
Sure.
maybe conceptually not clear, like, okay, there is a threat at Unix level launch, and it's saying, okay, I need more, and you're saying, okay, there's no correlation second one, but I think there's a few gaps I have to like clear up, but I get this.
Awesome. Okay.
So another question that was asked here, and we've talked about this a little bit, is specifically, it was, might as well just read it. On your Docker definition, can you configure the amount of hardware needed? And I think that speaks to whether a container is abstracting your software application from hardware at all.
Right.
And maybe you could speak to a little bit about whether I even said something that made sense there. And how does that differ from when you just had VMs in the data center? Do you get freed of some kind of, like, what's the benefit? Whereas I think a lot of people, all of us here, say, well, this is an easy thing to think. Why can't I just do this with my VMs?
Right.
Yeah,
Right?
exactly.
So in the Docker file itself, I don't believe you can specify the the CPU or the hardware requirements around it. You can find the networking and the ports, you know, what ports are exposed, what applications you're putting in there, what base images you're kind of coming off of, right? Any kind of environment variables that you might want to include when you spin up your application. So what my database connection string is, or things of that nature. You know, those are the things that you can include inside of your Docker file. Where you want to, where you start talking about those performance requirements, that's when it's more into that other level, whether it's the YAML file at the Docker Compose level or the YAML file at the orchestrator level. So that's where you can kind of move those hardware or resource constraints around that. The Docker file is really, what do I need to build this application and make it run, regardless of the hardware it's kind of running on.
So are we trying to abstract our application from, decouple it from its hardware dependencies?
Yes.
Even though, I think you made a great point, because I never really considered this, is that sure, we've abstracted it and we think this is awesome, our software doesn't even care what hardware it runs on, but maybe it does, because it needs to have certain amounts of RAM
Yeah,
or storage.
you still have application
So-
requirements.
Yeah.
Sure.
For you know, non-functional, you want your memory,
Yeah.
you know, we've got long-running transactions or something that need a lot of memory. You know, your application may have those defined as its own parameters that are specified in the Docker file, and you better be sure that whatever node, the nodes that you're deploying on, which are essentially VMs,
Yeah, they are.
have that allocated to it.
So do you make selections, depending on what platform you choose, for how much hardware you want?
One of the things that the scheduler does as part of the orchestrator is it looks at the requirements for a container and then finds a node, a container host that has enough available resources
Good
to
point.
host that container.
Yep.
If it can't find one, then it's either going to kick back an error, or hopefully you have some magic other part of your orchestration that'll spin up another host for you and home it on there.
And make it, yeah.
Yeah.
So, yeah, I think that the sizing comes in with your host and not your container so much, you know, so making sure you have enough, you know, host resources available for, you know, kind of having that in your mind.
Right, and that's why in my mind I was moving that hardware requirement, not in the Docker file itself, but more up to the orchestration and the YAML side of things, as opposed to the thing that basically says this is my app and the images that I run from.
And one of the things you said, you know, why can't I just do this with VMs? Well, you can.
Mm-hmm.
You're kind of at what you're doing though with an orchestrator is you're abstracting that away into management of an orchestrator and let that take care of the VMs and spinning them up and spinning them down based off of what you need and what's in the Docker file, that, you know, for the OS that's on those nodes and such. So you don't have to physically manage your VMs at that point.
Yeah.
Well,
It's a good point. You certainly could, right? You have that the Hyper-V definition, basically of what my virtual machine looks like.
Okay.
You get other performance benefits by not spinning up VMs and spinning up containers instead. And that's where that's really why we're pushing in that direction.
So can we think orchestrator as like a cloud formation templates in Amazon World? Is it?
I'm sorry, repeat that again?
The cloud formation templates in Amazon AWS, right? Or can we correlate? Because it's it's a template.
Yeah.
Take it.
It's essentially a template. That's, I would say, that I'm not as familiar on that
Are those
on that
equivalent
side
to
of
the
it.
resource manager templates?
Resource management templates, cloud formation templates.
Oh no, it's not like it's not like a resource template in Azure. It's definitely different from that. In that it's not spinning up Azure resources. It is a similarly structured JSON definition
Okay.
of
I think it's a CDN.
properties,
It's
key
cloud
value pairs.
formation templates. Okay.
Yeah. So it's similar, but you know there are some differences for sure. Okay. All right. Any other questions? Because I think what we probably should do is we have we kind of talk around it a little bit, but one of the reasons we're here is an Azure group. What can you run? Where can you run these containers inside of Azure? So rough count off the top of my head, I believe there's 5. Let's
put 'em on the board.
There's definitely 4.
Well,
I can think of 4.
I can think of 2, but
all right.
Yeah.
So let's start calling them out. What we got?
Azure Container Service,
All right. So
ACS.
ACS, okay. An Azure Container Service, probably as we name them, we should talk a little bit about them. Azure Container Service gives you the ability to spin up containers and have an environment that has multiple machines inside of there. So you have a master machine, and that's kind of where your deployments run into, and all of your awareness and orchestration of your application underneath that goes. And then you have, n number of nodes that you spin up that your containers run inside of. So your orchestration engine runs in here. Your nodes with your containers would run inside of, however many of those you wind up creating and needing. ACS did give you 3 different orchestration engines. It would let you do the Docker Swarm. It would let you do DCOS. Those are still available and capable that are out there. But we used to also supply a Kubernetes orchestration engine inside of ACS.
Is that gone?
yeah, you said used to.
Used to. It is. There's another one that is the preferred way of doing Kubernetes
Right, yeah,
containers.
Which is
So-
the next one.
Yes.
AKS.
Right.
Well, so in ACS, where you have your orchestration engine, it's your responsibility, but you have to manage that.
Yes.
You get a node and it has it on there, but you're completely managing that orchestrator.
You're managing everything. Yeah, you own all of the components inside of there. You got to do updates. You're responsible for making sure and
Yeah.
pushing those updates out.
Moving you on to AKS there a little bit.
Yep.
Okay. Is that
Moving
what
along.
they mean when they say AKS is managed Kubernetes for Azure Container Service? I gotcha.
You got it.
Exactly.
So that's why we kind of broke those 2 out. This is recent. This was probably in the fall, if I'm not
October.
mistaken.
I've
September,
looked
October.
a lot in the AKS. It was October.
Was it October?
Yeah.
There you go.
October.
They all start to, they do blur together for me, I'm sorry. So the AKS side, you have a very similar structure in that you have your master nodes that handle your orchestration, where you can do your remoting into and do your deploying of your applications. And then also you have n number of nodes that your containers are going to go ahead and sit right in. The big difference is that we're using the Kubernetes engine specifically to do the management of that. But you also get certain components of this managed for you. So the master server is essentially managed for your environment. The updating of the Kubernetes, it's almost like a PaaS service, essentially, is what you're getting by going down this path. So that's why we're putting a lot of work behind it, and a lot of tooling, and a lot of effort to make sure that these are up to date and really robust moving forward. Questions around either of those?
So what does AKS make make easier for me compared to I did a Docker Swarm in ACS, and I was remoting into the host and connecting clients and setting my doing command line commands for adding nodes and setting my swarm count and all of that sort of thing. It was a very manually managed thing.
Sure.
So what do I get now from?
So from that, you still have the ability to manually manage all of those, container instances, or the number of nodes that you've got created, or the number of deployments you have. You still have the ability to manually go ahead and manage all of those pieces there. Where we're managing on the AKS side is around the orchestrator engine itself. So being able to update that orchestration engine going forward. So as we continue to, or as the team that runs the Kubernetes component continues to push the update that software, those services would continue to get managed as well. Plus, you also
It's also part of the console.
I'm sorry.
It's part of the console also, right? So you can script it.
You can, yeah, exactly. You can.
You're not remoting into a machine or anything.
You're not. No, you use the kubectl tool, and you're able to go ahead and script those components out. So
So you're saying ACS I have to do remote into all these
I
different
don't know, I was just going off- I don't know
and
about
AKS
ACS,
I can script it.
going off
That's
what
a
he
big
said.
difference there.
I think ACS,
That's what it's
depending on which orchestration engine you
that's
use,
what it comes down to.
ACS is it's a higher touch out of the 2. I think so. It'll spin up the initial framework, and then I think you can still spin up additional nodes through ACS without manual config, but then the patching and the care and feeding of the nodes and the master server is kind of up to you.
Okay.
AKS, all of that is kind of managed for you, at least a decent subset of that is managed for you.
Yeah, so like mid last year when I did the Docker Swarm configuration, we had to basically it would set up how many ever master nodes I wanted, but then I had to go configure, you know, running all, you know, how many instances, how many nodes I wanted running on those hosts and that
Yeah.
sort of thing.
Yeah, and they're kind of taking that backed away from that on the ACS side a little bit.
That is good news.
Yes. Okay. So that's 2.
ACI, Azure Container Instances.
Okay. And that is essentially the ability to spin up individual instances of those containers based on the Docker file. So I might have a need where I want to burst workloads into Azure, and I could run those container instances, have those be spun up and needed off of some kind of an orchestration engine or something of that nature, where I could push that container, bring it to life, make it do its work, and then when it's done, it just goes away. What's great about that is it's one of those services that you only pay for the compute time where it runs, right? Much like much of the services in Azure. So because you're only bursting and spinning up those ACI container instances very quickly, you're able to do what you need to do, get in, get out, and there's no additional overhead of all of the other nodes and services that might be sitting up there.
So
So
I
it's
don't have a host VM and all of that kind of stuff
Right.
Right.
that I have to
That you
worry
have to
about.
manage. Yeah, it's almost like the serverless stuff.
So
because-
it's a container without management, maybe. So like, it might be something great for you as a dev. I just want to see it work.
Yeah, exactly.
Yeah,
Let's
but
spin it up.
even for
There's
small-
2 use cases.
Okay.
The first use case was I'm just a dev or I want to play around with containers real quick. Here's a way to do it without setting up any of this other stuff.
Right.
Give me a container, but you got a container. Now they've added support for some orchestration around that with Kubernetes using the virtual kubelet.
Yes. And
It's interesting to see it all come meet back in the middle.
Would a use case for that, if you, let's say you've got some sort of enterprise level application, multiple containers running all over the place, managed by Kubernetes, but you know, you've got a business process that, you know, is predictable and schedulable, and you know that it's gonna, you know, it doesn't need to run all the time, just needs to burst up. Could you technically have a container that's running in one of these other orchestrators spin up an ACI to run that job, and then, you know, as sort of a temporary, you know, go do this and then be done with it, and then continue the process on in our AKS or ACS environment?
Sure, I definitely could see that happening. Now I know you mentioned functions. That's kind of, you know, you really.
Yeah.
But if you've already got that application or that process or that service running inside of a container, then it's already kind of on that container path line, as opposed to if you were going greenfield and you knew it was only going to be run on those, you know, on-demand kind of things, then yeah, a serverless function might make better sense. But because I've already got that code, I already have the muscle memory around spinning up containers and have my application run inside of there, that just is an easy way to make that work. Question? All right, what else?
Service fabric.
Service Fabric is another way that you can run containers, absolutely. So there is, as you mentioned earlier, Service Fabric then becomes that orchestration engine, so you don't have to worry about spinning up additional orchestrators. If you've already got an application or parts of an application that you're building inside of Service Fabric, then this might be a way to do a container kind of workload that makes sense, but have it still running in this environment that you've already got created and up and running there. If you're, you know, working with primarily on the, you know, in the C# world, you're already kind of got that memory or that muscle memory around building Service Fabric instances and services. That if I'm building an ASP.NET Core container, then it makes sense for me to go ahead and stick with this world as well. So there are things why you might want to say on the Service Fabric, because you might have it up and running for other reasons, and you've already got an orchestrator there built into it, let's say. Not completely answering your question, but.
But is there, is what the situation I described of just creating off of a Service Fabric template, in Visual Studio and creating ASP.NET Core API. That it's basically a web API with, you know, a side project that helps integrate with Service Fabric, and there's the manifest XML, and there's all that kind of intertwined integration into the Service Fabric stuff.
Okay.
What would be the difference between going that route versus, all right, I'm just gonna, you know, .NET New API and put that in a container and throw that out into Service Fabric? Is there much of a difference between the two? Because there seems to be, when you're doing that template of the Service Fabric template, there's a lot of overhead and additional stuff that's involved in that, you know, solution versus containerizing, I don't know what to call it, like a plain old REST API.
Right.
But it's lighter weight than the additional overhead that's involved in that Service Fabric API template.
I'll be honest, that is a really good question, but not something I've played around with to be able to say conclusively what's, you know, these are the differences. But I would definitely take a look at it and come back to that. But it's that's a good point. I don't know if anybody else.
Some of that, I think, your domain knowledge and experience and expertise, like, I don't know, for me, when I got into the Docker file and, you know, Compose, it was like a very different way of, you know, thinking about, you know, how to build these things, and, you know, it's like all this new syntax and format. So, I think the Service Fabric felt more familiar to me coming from a, you know, Microsoft and C# kind of background. That seems like part of it.
I can see that. I mean, the first couple times I ran through Docker containers, you know, and trying to build a Docker file that wouldn't run and build my container, yeah.
And getting them to talk to each other and setting up the VLAN and, you know,
Sure.
and all that stuff. So
yeah, I mean, that might be that's a really good
Yeah,
parody
like
example.
Service Fabric is, I just want to concentrate on the code and get all the benefits of microservice orchestration and stuff. And it's interesting that they support you using Docker. Again, this meeting in the middle from different abstractions.
Yeah.
But, you know, it's not that, I think what's made these other services popular, like AKS or something, is the idea that you're not wasting your time learning Docker. It's a portable skill. It's not like you're learning something centric to a vendor or anything. You could take that skill and go off to Google Cloud or Amazon or your own data center.
Yeah.
So I feel like Service Fabric, which I think is older than a lot of these, was the very high level abstraction. You're going to hit file new, you're going to concentrate on code, and we take care of the rest. But then people started saying, well, hold on a second, I have this portable skill, Docker, Kubernetes, and so on.
Yeah.
Why can't I use that on Azure as well?
On Azure or
On Azure, like
Okay.
on AKS,
Yeah.
right?
Yeah.
Or these other solutions.
Yeah.
We're on the 4 now.
We're on the 4.
Yeah.
4. Okay.
Deploy it on IaaS.
You could.
Build it yourself.
I've got another one that you probably know I'd be focused on, right? Is Azure Web Apps on Linux.
Yeah.
Is you can point at a container and say, this is what I want deployed. It's very demoable. Like it's awesome if you're saying, hey everyone, I'm going to introduce you to .NET Core today, and look, .NET Core, magic, command line, look, now it's running on Linux, and oh, look, it's in Azure because I pushed a Docker container up to Docker Hub. So I can do all that in a demo. It's very demoable. People think you're really awesome, and then I have to admit to them all, I really don't know anything about Docker. I really don't know anything about Kubernetes. I just learned enough to follow this thread, which is that's not bad as a developer. It's not
Right.
bad to tinker. I recommend, everybody give it a shot. But, you follow that path and you really don't know a whole lot about what you did, right?
Right. You just go, hey, it's up there.
Hey, it works, and look how easy that was. And it's on Linux too.
It's
Hooray!
Linux. Exactly. And that's, that was one of those things that was kind of, because it was so easy to do, and it was kind of that branching point of getting that .NET developer to get comfortable and saying, hey, my code can run in a container, and I'm okay with that. So that definitely, that web apps on Linux is, while it's great for demo and it's really a neat way to kind of get your feet wet and up and running, we've since come up with a lot of these other things that really make the container piece much more palatable, if when we're spinning up this, we're not spinning up like we do with a container and dropping additional container instances inside of the nodes that are there. We're actually, spinning up much like we do on the web app side. We're spinning up as part of those app services, and so it's not a true way of doing that. Not typically how you would truly do a container instance. Does that help you fight a battle back in the office, or is that?
Did you just win?
Nice.
That's why we're here.
Yep, glad to help.
No comment, because I'm gonna send them this to watch on YouTube.
There you go.
I mean, once again, it's the what do you need
Yeah.
issue. If you're building a website for your user group,
Yeah.
maybe that's a great option, right?
Sure.
Low impact, low touch, low thinking, works.
I can say it runs in a container.
Runs in a container. I'm not thinking about it.
Hey, this user group needs a website. Who's volunteering?
I mean, I'm just saying, right? I'm not trying to minimize that use case.
Don't use that.
Because a lot of times I think, we go straight for, oh my gosh, I've got to have a managed Kubernetes cluster, and I'm still not 100% sure what I just said, and now we got to skill up on this, and you sort of do it anyway, and you stub your toe.
Yeah.
Question on Linux versus Windows
Yeah.
containers. I seem to have this feeling that I should favor the Linux containers where I can, because of their smaller footprint and like size and memory, and they're faster to spin up. When do we get to a point where we have a 50 megabyte Windows microcore or something that runs in a container?
Funny you should mention that.
So I don't have any roadmap or where that's headed, but as you've seen it happen over time, we've gone from it being, gigs of an image size down, and it's continuing to get smaller as we start to work through the .NET Core and the server core.
With a server core, nano server.
There you go. That was the word I was blanking on.
Nano server is a container now, right?
Yeah.
Yes.
Only a container. And they've gotten that down to something in the 100 meg territory.
It's getting that far down.
I
Okay.
thought it was below 500.
It's definitely below 500. I think it's down in like the 180 or something now. Because the most recent, like the 1709 release version of it, they basically stripped out everything. So Nano server by itself has almost nothing to it, and it's up to you to, in true container fashion, layer pieces on top of it to get the functionality you need. Which is why they killed all the other aspects of Nano server. So you can't run it as a file server. You can't run it as a bare metal server. Sadness.
So that's the direction where it continues to head. There are reasons why you might want to use a Windows container for your application, right? So one of the things that a lot of the stuff we talked about is like, I've got a new application, I'm gonna start with a new Docker file with these images, deploy my application, boom, we're off and running. What if you have, we talked in the past with the infrastructure as a service discussion, or IaaS discussion around lift and shift. What if you could lift and shift that application out of the hardware it's sitting on into a Windows-based container running on IaaS in whatever version I need it to, and I can now take that container and move it up into Azure. I'm now getting away from those dependencies inside of my data center, and I'm starting to get things moved to the cloud. Granted, yeah, it's probably an older application, older framework, it might be a little monolithic, but I've got it up there and it's running, and I'm happy with it because I really didn't have to change much of the code. I just basically had to push it into that container that's sitting there. That certainly is one use case, and then now that it's there, I can start looking at that application and saying, well, what are the possible services that I can start pulling out from there, and pull those out, redo them as microservices going forward, and then use that to be able to talk to. So it's a way to kind of get that foothold in Azure or in containers out of your data center, regardless of where you put containers.
So like maybe you depend on .NET Framework, maybe you depend on WCF.
Yeah.
These could be Windows containers.
Sure.
Right.
Yep.
Yeah, the server port container can support all that stuff.
Yeah, so again, it's like you said, an alternative to lift and shift, where instead of just, I went from a data center VM, which I still got to manage and care for and feed, to a cloud VM that I still got to manage and care for and feed. This is the whole, I just want my app up there.
Yeah, because
so
that's
that
what
I
they
can
need.
bring up and down containers at will and not, they're not my pets anymore.
Yeah, and it gets you away from, we're not in that space yet, but at some point, Windows Server 2008 R2 is going to hit end of life in the next year or so, right? You know, where I think it's 2019 timeframe, roughly, for that. So I might have applications that are sitting on that. This is a way to get them out of there without having to migrate them to a whole other farm, and how are they going to run on there and things of that nature.
Based off of the Linux or Windows kernel, are you limited on which orchestrators you can use?
If you want, like, if you want to do Windows containers, could do all
Can
of those
AKS
orchestrators.
do Windows containers? Well, they can't, but
Sorry?
I don't think they can.
I don't think they can either. I'm trying to
It's
originally
coming,
could.
from what I've been told, but
The beta Kubernetes, like 1.9 or something, can do Windows hosts,
yeah.
but it's not in the stable channel yet. It's still beta.
Right.
And AKS is still a beta, right?
It's still preview.
Yeah, it's
Preview,
still
yeah,
preview,
preview.
public preview or
So
beta.
Since October, so I mean it's only been
So,
4 months.
It's all
Have,
beta.
going back to the
Always
question I asked a
beta.
while ago about
Everything's beta.
which one do you choose, that you need to take that into consideration too. If you've got a mixed environment of .NET, different versions of framework, or Java, whatever,
Mm-hmm.
that needs to play into that decision of which orchestrator to use.
Absolutely, yeah. And you know the fact that you can run Windows containers now inside of Service Fabric, you know that may spin you in that direction versus not. I mean, for me, it's kind of a bit of a continuum, right? We've got yes, it demonstrates the web app on Linux framework. You know, ACS is a way of you know kind of kicking some of the orchestrators that are out there. AKS is kind of really the way we're heading, and then Service Fabric is kind of that, you know, I think
Stable.
the more, sorry?
Stable.
Stable,
Seasoned.
but I think more of where C# shop, we've got a good development, DevOps kind of muscle going. We're able to really continual deploy applications to Service Fabric. We have the engines and the Service Fabric engine be able to understand if I deployed bad code and be able to do the self-healing. So I think if you've gotten more of a mature development shop, I think Service Fabric kind of puts you in that direction. Certainly on the C# side of things. If you're more open source, Node, Java, you know, things of that nature, Linux side, you know, you're going to be more on the AKS side of things there. So.
What if you're all of
Uh,
that? I mean, I guess there's no reason you can't run.
You do both.
You could do
Yeah.
both, but really, I mean, it's a management issue.
Right.
Yeah.
If you're both, you would probably want, and this is, you know, an opinion, I would say, you know, if you're running both, you might want to be from a management perspective, you're probably going to want to manage one of those too. So you would probably pick the one where everything's going to run. But again, it depends. But that's, you know, if you're, you know, kind of throw everything together, that's one way to make a decision between the two.
Yeah.
One thing we missed. There's something related to ACS called ACS Engine. And what that gives you, while it's not something you can go out to Azure and say, I want ACS Engine to as a construct to run, it gives you the ability to define the various components that are going to be inside of your container environment. So it gives you that you can choose the orchestration engine, so you can choose the orchestration version specifically of that engine and not be relying on what's going to be out here in the ACS world. You can define, you know, the additional settings that you might need that are specific that you get for free and automatically by running the ACS world or in the AKS world. So that's a way for you to kind of really customize and make a container services environment specifically for the application that you're running with the parameters that you want to run against. So that's it from the engine side of things. The only other thing that's related, well, not the only other thing, but an important thing that's related to containers is ACR, which is Azure Container Registry. So much like there is a Docker registry that's public and freely available, there is also the Docker registry that we talked about that's private. ACR is one of those private environments. So you, for your organization, can define the images that you want your developers to use, store them up in ACR, and what's great about that is for any one of these services then, if I need to spin up an ACI instance real quick, I've got that image sitting over in ACR, and I'm able to go ahead and have that up and running. Same thing with any of these environments here. So ACR gives you that ability to locally store and secure the images that your environment, that your organization needs to build your containers against. And I think that's all. There are other containers that are in use. Everything is, or a lot of things are starting to work towards containers. When we talk about SQL Server runs in a container now, runs on Linux in a container. The Cosmos DB emulator runs in a container. So there's a good bit of containers that will be part of your life at some point, regardless of what parts of these various Azure components you wind up working with. Questions? Comments?
Not on these 5, but I do have some questions on authentication and authorizations, how this work. But I would like to take that offline because
Okay.
it's all
We can do that. Definitely. Let's chat after. Okay. Cool. Safety 22.
Perfect.
Okay. Thank you, everyone. Appreciate it.
All right, we'll take a quick minute. We're going to switch over to the second presentation.
You gonna do that lightning quick? That switch?
Wow.
Where's the clock of thunder? Oh, you need to switch up here. Yep.
Don't need that, so put those back on the live stream. Whoops. All right. No. Sorry, technical difficulties, mostly user error. So we are switching over to the Azure Service Bus presentation as soon as I actually open the right one. All right, there we go. So that was a quick switch. Hopefully, I think I did that in under a minute. So we're going to go to the second one. This is the lightning talk for the evening. We're going to talk about Azure Service Bus. I don't have the Mixer feed up anymore, so just flag me down if there's any questions coming through on there. Otherwise, if you're in here, feel free to raise your hand, shout out, whatever you need. And once again, this is being recorded, and we are obviously live on Mixer, but we will put this out to the Philly Azure YouTube channel once we get the recording, and we'll put that up right away for everyone else's reference. Also, follow the speakers. I think we're putting them in the Mixer feed, but follow the speakers tonight and the Philly Azure user group on Twitter as well. All right, hopping into this, I think audio should be good. I'm sitting pretty close to the mic and talking in that general direction. What I want to point out first is with Azure Service Bus, there's really two main parts to it. There is the original part of Azure Relay, and then there is Azure Service Bus messaging. And I'm going to talk about Azure Relay first, and then I will contrast that with what most people, I think about when it comes to Azure Service Bus, which is the messaging component, the asynchronous part. Quick show of hands. Who is familiar with Azure Service? We'll just say familiar. Anyone in the room familiar with Azure Service Bus? 1, 2, okay. 3. All right, we'll take 3 in the room. My next question was going to be who's using it from any type of perspective. I will say it's probably who's using it at work, at their job, who's using Service Bus for things, messaging or relay. Okay, cool. So a couple people in the room, hopefully some on Mixer as well. So going to what we're going to say is Azure Service Bus messaging patterns is usually how it's referred to. There's basically two. I talked about this already. There's Relay and there's Service Bus messaging. But when you say service bus, quote unquote, overall, you're talking about this. This is the high level part. This is a multi-tenant cloud service. It's served by multiple users. I think at the premium level you can get that isolated to your group. Each user within an application, either developer, you can create a namespace and you've got communication mechanisms within it, but when you have it in your tenant, it's going to be across that. So everyone can leverage it and you just create your namespace. And within that, you would then create your queues or your topics or your relays or whatever you need to use within your organization, within your Azure subscription that you want to start out. So you have multiple namespaces within it, and within that you're going to use multiple messaging patterns within it. I just wanted to show this slide so you can just visualize top down. We have Azure, and then we have Service Bus, and then we can start isolating in namespaces and then isolating in queues and relays and stuff. But that's just your breakdown of Service Bus. As you can see from this image, we also then have different applications can interact with different ones as well, right? This is just how this is your architecture. This is how you're going to set it up, break it out, how you would need it. And before I get into the details of this, I bring this up because as I did some research and I needed to know this for work, there's just a lot to this. I'm going to gloss over it, but I found this really fascinating and what it can be done. If you are working in Azure and you are starting to get into those developer and architecture patterns, this is something I recommend everybody look at right away. If you're not familiar with what you can do with Service Bus, it will instantly be relatable to what you are doing at your job, right? Normally I would assume when everybody looks into Azure, they start looking into VMs for your infrastructure as a service, because that's the easiest thing for us to relate to, right? I know VMs, I can do VMs in the cloud, and then I think as the developers, a lot of us immediately do what we did last month, which is look into web apps, and then that comes with web jobs, and it comes with this and that. That's the next logical step for a lot of us. That's what we want to look into. As an architect or a developer or someone who uses Azure at their job, the next step is to start undoing those normal patterns in our brains of how we know how to do stuff and start looking at what we get in Azure. And there's a ton. I'm not an expert by any means. I've only just started scratching the surface, and I've chosen different things to focus on, and that's what I will be bringing to this group. If anybody else wants to do one of these, which is basically a lightning talk, pick your favorite thing in Azure and bring it to the group, and we will happily have you. You can do the last 15, 20 minutes of any night and session. But the more you know about this, the better. I just saw a resource. I just saw a Pluralsight course that came out. It's called What to Use When in Azure. I just started watching it, so I thought it looked pretty good. I can't remember if we can find that URL. I can tweet it later. I think I might have retweeted it already. But so it's that kind of thing, right? When you are now a cloud architect at your company or an Azure architect, you need to know these types of patterns, and it's different than what you're used to doing on-prem all the time. And like I said, if you don't know where to start, I've kind of walked you through what I think, the first one, infrastructure as a service, and then your Azure web apps. I highly recommend coming to Service Bus. I find it instantly usable and relatable to a lot of things that I would have done on-prem, and this seems more efficient and a better pattern when working with the cloud in general, and especially Azure. So wrapping up the beginning part of this before I jump into Azure Relay is just overall, when talking about messaging patterns, now we're starting to break it down a little more. I started out by saying we have relay and we have messaging. Within messaging, there's really two. There's queues and there's topics, and then we also have relays. So we'll say when you set it up, you can do a queue, which is a one-directional communication, and we'll get to that later. Sometimes it's referred to as a broker, so if people start talking about Azure Service Bus and they start saying brokers, that's what really we're talking about. It basically just stores your sent messages until you get it, and then each message, so here's the key for queues, messages, they can only be received by one recipient. There's patterns for this that we're going to talk about, like competing consumers pattern, which we'll get to later in this presentation, but just know, queues, one person's going to get it. It comes in, and one person's going to get it on the outside, or one service or one something is going to get it and deal with it. Whereas topics is a one-to-many, right? So you set up subscriptions against the topic. So messages come into your topic, and then multiple people can get the same message because their subscription is based on a filter, and that can be overlapping, right? And then lastly, so those are kind of asynchronous, come in, one way in, one-to-many out. It's asynchronous. You don't have to be online at the same time. Those sending in the messages, send them in as they want, and those getting the messages, take them out as they want. You don't have to be online at the same time. It's asynchronous. Relays, Azure Relay, is bi-directional communication. Both people or both machines have to be online at the same time. It's like so let me throw this out there. So when you're trying to imagine how this works, or you're trying to explain this to people, queues and topics, so your basic service bus messaging, that's like the postal service, right? Somebody sends something out, there's a broker in the middle, and then somebody gets it in the end, right? A relay is like a phone call. Both parties got to be online at the same time to make that happen. That communication is bidirectional, whereas postal service is asynchronous. One sends it out, and then they get it, and then you can have a response if you need, but it doesn't go back the way through like you would with a relay. Relays are also really nice as a pattern because you can have two outbounds, and then that can come inbound, which I'll get to that in a minute. But if you're thinking about this, right, when you're talking about Azure Relay, actually that's going to be on this side. If you're thinking about Relay, you can have both sides go outbound. So one of the biggest things when you're setting up a hybrid setup is you don't want to enable inbound traffic to your on-prem setup. You just want outbound connections. So Relay is perfect for that because you say you've got some things in the cloud and some things on-prem. You only have to enable outbound communication. You both hit the relay makes the connection, and now you have bidirectional communication, and you didn't have to open up those inbound ports. So that's really the high-level takeaway of Relay. I'll go back to the previous slide. There's a lot more to it than that. We're talking about WCF. There's a bunch of stuff to it. Y'all can read the slide and get an idea of it, but as you see from this slide, again, the biggest thing was you don't have to open up inbound on your corporate intranet for your firewall, things like that. You can both point at Relay and get bidirectional communication. And then there's a lot more to this. Again, this is a lightning talk. The key takeaways from an architecture perspective is that's what Relay does. That's really the highest, most important part of that is both outbound and that it's bidirectional, outbound TCP connection, et cetera. You can both establish out, and that's it. That's basically what you need to know about Azure Relay. If you need to utilize it, obviously you're going to jump in. At the end of this presentation, I've got a bunch of references for Relay and Service Bus. These are also both posted to the Meetup site. So if you are listening online or if you're here in the group and you want these, they are already posted to the Meetup site. It's the first comment from tonight's meeting. So also the intro slides, if you need those for some reason, those were posted as well. So you got your high-level takeaway from Azure Relay. I don't want to gloss over it too much, but I really want to focus on the other part of this. And also, this is a lightning talk, so this wasn't meant to be in-depth by any means.
How fault tolerant is the connection that it establishes? Like if that goes down, does it reestablish? Is that something I've got to code?
Great question. I don't know. Anyone else in the room know? I think it does. So let me say this. I think it does reestablish. I don't know how fault tolerant it is. And I think we can look that up and post that either to the stream or we can tweet it out. So, good question. So while they're looking that up, hopefully we'll get that in the stream or we'll tweet it out after the fact. But I want to talk a lot about service bus messaging. Again, we talked about the two options, queues and topics. Basically, again, in contrast to Relay, which is real-time, bidirectional, synchronous, service bus, again, asynchronous, temporally decoupled, quote-unquote, is what I'm doing with the air quotes in my fingers. You don't have to be online at the same time. The first one, again, is queues. Queues offers first-in, first-out message delivery. As you can see here, to one or more competing consumers. I will talk about a competing consumers pattern, I think, later in the slide deck, but basically they come in as much as they want. You've got your queue. You're now decoupling where you have the messages and what you want to do with them, right? A lot of times when you would build architecture before this, you would have to build your system to either scale quickly or to handle peak load. With Service Bus, you now use what you can do what's called load leveling, right? You now only have to build for the average load because you can put all of your incoming messages and things you need to do through a Service Bus, and then you can only have a server that just goes and picks them up, not as often as they come in, but as often as it can handle. So now it's running at that level, which is your average level versus your peak level. So it's a way to load level the way you handle your message traffic rather than having the server get it directly, which would have to handle peak traffic, if that kind of makes sense. I think I have a slide coming in for that. But again, just remember, message queue is there. One or more can go get it. That's competing consumers, and I have a slide for that. For this one, only one is going to pick up that message and do something with it. There's only one consumer. Even if you have many consumers assigned to your queue, each one is only going to pick up one. If you need to have more than one system or thing pick up the message, then you need a topic with a subscription. So quick look at this when it comes to queues. Basically, you got a sender, goes into the queue, it sends a body, it sends some key value paired properties within the message, and then it goes out the receiver. And again, the message is going to be similar if you're doing a topic and subscription, because you can then filter on those key value pairs that you see here in the queue. So I started talking about this, and I now remembered I do have a slide on that, and this is queue-based load leveling, right? So again, if you have a number of tasks pushing messages into the queue, and you look at, you can't see this online, but you can in the room, requests received at a variable rate, right? You're getting all of these messages and requests coming in at different peak times. But your service that processes these, again, can process them as it sees fit or as it can handle. Again, this is an architecture pattern where your concern is now having the architecture in place to process, the average versus having to process the peak. And that is really key for scaling up, scaling down, or doing a minimal amount of hardware scale in Azure or on-prem, depending on where this is at. As I talked about before, the competing consumers pattern, this enables a pool of consumers to handle the messages, right? So now you can have multiple ones picking up. So if you have so many messages that a single consumer isn't enough to handle that, well, here's your scaling pattern. You can add more consumers, and it's called competing consumers because only one consumer can take each message, right? It can't go to multiple consumers. They're going to compete to get that and take those messages and do the work. Now, there is a lot of things that is here. Again, this is a high level to dive into how the consumers get the messages, how they compete. They can take a peek at it, but not actually consume it. They can do a delete. They can do or not do a delete. There are a number of sub patterns here that you need to know about. I'm here to tell you that they exist. When you start going into this, start diving into how your consumers read messages, delete them. There's dead letter pools, things like that. There's a whole much more to this that you need to know does exist, and you can dive in when you need to. Again, check out all the references in the videos, the podcasts, and things like that related to Service Bus. But I'm just here to tell you this is the high level. This is what you need to understand to start, and then please dive in as much as you can afterwards. Getting into topics and subscriptions, right? So again, in contrast to queues, which is a one-to-one, this is a one-to-many. Again, you've got multiple senders coming in, you've got multiple subscribers, and it is based on a filter. You now can subscribe to that subscribe to that topic with a subscription and get it. So this is a one-to-many out, and you can see where this would be useful versus a queues pattern, right? So it just depends on what you're doing. And again, this is all just the average Azure Service Bus subset of this. What I don't have time to do, and what I will hopefully do in a later session, possibly at the what's the event coming up? I just can't think of it now. Global Azure Bootcamp. Maybe I'll have an expanded one for there. I hope, or maybe I'll ask Rich to do it instead. Just kidding, Richie. Is how do these all link together? So there is a larger pattern in play here where you would link in with, say, CDN and IoT and Azure Service Bus, because you can see there's an upper limit to where Service Bus is useful as well. At some point, you may have to go into the Azure IoT hub to handle in your millions of messages. Then that could then parse them out and send some to Service Bus, send some to another thing, figure out, do some need to go to topics, do some need to go to subscriptions. Also, though you pay, and this gets into the pricing, which we don't have time to get into, but you pay a different way for different things. So, and you also pay by messages size in some instances, and so you can see right away where this comes into play, where you would hook this in with Azure CDN, where you would only want to send a message over. You wouldn't want to send something large in the message payload. You wouldn't necessarily put, like an image or something in your message payload. You could, but you wouldn't. You'd want to throw that into Azure CDN and just send the reference to that through that. And then that way, whoever picks up the message can then act upon that image. So say, oh, I need to resize. When I upload an image, I need it to be resized in 6 different ways because this is for my avatar or whatever, right? This is your average generic situation, right? But you wouldn't send that image through the message. You could, but you wouldn't, because you'd put it in CDN. You'd have the message post. You'd go pick it up on the other side, get it out of there, or just not in the CDN. You would have it go into Azure Storage, and then you would post that from storage. Maybe that would see it with a function and push it out to a CDN when you were done, so that way your image is then global, right? You see how this all goes into a much larger pattern, which we don't have time. This part we're going to focus on Service Bus, but just be aware that there's a larger part to this. Next, what I want to point out is Microsoft Azure says they don't provide a queuing mechanism that supports a priority queue, which is also a known developer pattern here. I hope everybody is at least familiar with the priority queue pattern. If not, please check out the reference. They don't do it built in. However, it can be figured out. You can do this with having a high and a low as one of your filters, and you can have multiple subscriptions going in place where one only pulls, you've got multiple consumers pulling high and multiple consumers pulling low, and that is your basic priority queue pattern done when that's not a native functionality of this, but that is something that is immediately thought of when you are doing a queue pattern. Yes.
So, sorry if I'm oversimplifying, but is this service like Rabbitmq? Solves similar problems,
Yes,
but has more. Maybe.
I think so.
Okay.
But yes, I'm not super familiar with Rabbitmq.
That's
I
fair.
understand that, or MSMQ, or
MQ series.
right, something to that.
Pretty
right.
close.
Very
They also-
similar,
They all solve the patterns.
right?
For the queuing and everything.
I'm not familiar with the full feature set of Rabbitmq, so I don't want to
Right,
say
neither am I.
anything about that. Directly, I can say I'm just glossing over this. There is a ton of what is available in here from a feature set, and obviously this is native into Azure. So I would maybe in a future talk I can look at a comparison of messaging patterns. So I don't want to say anything about them, since I'm not familiar with them, except I've heard of them, but that's about the extent of it. So if anybody else in the room has used them and has a comment, please. We can. Otherwise, that can be something we can look into. Wrapping up, because I'm running out of time and there isn't too much left to this lightning talk. Here's the takeaway for Service Bus pricing, and then I'll talk about the tiers. Always just go to the website. Do not trust anyone who has anything on a slide. It will probably be out of date by the time you are seeing it. It gets updated a lot. So I always do something where I do this. It doesn't matter when I'm doing this presentation, I will click the link. And if a question comes up where we have to talk about pricing, because things are always changing, and not necessarily a bad thing. They have introduced the premium tier, I don't know, within the last year. It went GA, right? So that's something that has to be known. And if I only had this slide and I never referred to the other one in my talks, I may not have noticed something else went GA. So please always check the live one. I do want to talk about tiers. When you talk about Service Bus, there are 3, and you can kind of see the differences here with how you want to pay for. The thing I want to point out on this screen that I found to be most important, especially if you are an enterprise level architect, which is what I am, which is resource isolation. It's not showing up on the screen. So if you look at resource isolation, it's the last one. That is an option in the premium tier for this. So if you have requirements, data sovereignty requirements, or you have data integrity issues, things that require you to isolate not only your data, but how and what touches your data and processes your data and things of that nature, you want to look into resource isolation at the premium tier here. And that is, again, premium tier is only, I think, don't quote me on this, within the last year became GA. So this hasn't always been available, and now it is. So please check that out if you have those types of needs. I talked about this earlier. I do have a bunch of references. Again, this is a lightning talk. These are most of the references that I used when putting this together and doing research in general into Azure Service Bus and Azure Relay. All of these I found to be really, really helpful. Please dive down into them as you need, but this is definitely where I have it. And again, these are posted to the Meetup site, so go grab them from there. And I think has the link been posted in the Mixer feed? If not, we can. Otherwise, go to the Meetup site and grab them from there as well. If you have any questions at all, reach out anytime. I know we're running out of time for tonight, so I'm going to wrap it up with that and take questions, and then we'll be good to go. Cool. All right. Thank you very much.
Quick question. You
Sure.
mentioned IoT Hub and scale. Is there a general guideline for scale on Service Bus, like what it can handle, as far as load?
Rich, I saw you nodding your head. Go ahead.
There is the numbers. I'll find I'm sure the references were somewhere in
Somewhere in there.
but there is. It's definitely posted with the scale of those for each one of those.
Yeah. It can handle and scale a ton.
Right.
I think I don't know what the upper level limit is of it versus IoT Hub. It can handle a ton of traffic. I think part of this decision comes down to pricing, where what do you throw at the Service Bus versus if you're talking millions of IoT level transactions. You don't have to use IoT for IoT.
Right.
We're just talking
Yep.
messages at scale, and at some point, since the IoT Hub, so a little bit of the backstory is. Relay came out first, then Service Bus came out, then IoT came out, right? And it came out because of needing a scale at Service Bus to be handled, right? So not saying the Service Bus can't scale, saying is that handles that next level, and you're going to want to look into both the scaling upper level limits, and you're also going to want to look into the pricing for both of those. So there are limits to the size of messages that you can send through, and then there's a cost associated with that, the way it breaks down, how many messages you can send. There's a maximum limit to your queue as well. It's like 5 gigs, I want to say. Don't quote me on that, look it up in the references, but it's around 5 gigs, I think, is the upper level limit of your entire queue for each one, right? So now, and this goes back to why we would use Azure storage versus putting it, you want to have a small message payload so that you're not blowing up your queue at the max limit with anything that could be put into Azure storage and then referenced when you picked it up, right? You pick up the message on the other side, then you go get whatever you need out of storage if that can be done, right? So there's an upper level limit to your messages and to your maximum queue size, and then again, that's why you would start looking into the Azure IoT Hub to be your initial place where you send, if you're doing messages at scale, send them into there, have that parse it out, send what you want into queues, into topics, into somewhere else, parse those blobs, put them into storage, and then come get them on the other side as you figure it out. Any further thoughts, Rich, to that?
Just two things around that. One is you also have Event Hub.
Yes.
Because it also is a way of quickly ingesting messages. It also, if you don't need to do any of the topic subscription, those kind of things, then Event Hub is just straight ingestion of the messages. And very similar to the IoT Hub environment. IoT Hub not only will do the message ingestion, but it also does secure device communication. You can do device to cloud communication. So there's a whole bunch of additional features you get by going that route that you may not need. The Event Hub might be just enough.
Right. Great. Thanks.
Cool. And we could do whole lightning talks on each of them
Right.
as well. Again, because this was what I dove into, but if you go through these, as you start looking at the examples online, you will also see some of those larger patterns scale up at the end, where this leads you to that conversation, and then at the end there's a nice diagram, and I don't have it, I should have put it in my slides, but at the end it was, and then here's a much larger scale piece with all these parts hooked together, and this is why you need to know about this, and again, this is why you need to look at each architectural piece and say, I need messages, I need storage, I need scale, I need this, I need that. So cool. That's it. That's all I got. So I think we'll cut the mixer feed. We'll stop the recording. And thank you all for joining this month for the Affiliate Azure Meetup group.